Welcome learners. Today lesson is energy changes in physical and chemical processes. Subtopic is bond breaking and bond formation in chemical processes. Chemical processes involve bond breaking and formation of chemical bonds, e.g. covalent bonds. So we start by looking at what is enthalpy of formation. Definition is the enthalpy change that occurs when one mole of a substance is formed from its constituent elements under standard conditions. Now note that bond breaking occur on the reactant side. To break a bond, it is absorbed. Hence, enthalpy change is positive, i.e., it is endothermic reaction. Bond formation occur on the product side. To form the bond, it is released. Hence, enthalpy change becomes negative, i.e., exothermic reaction. Now, enthalpy of formation, the overall enthalpy of formation is positive brackets if the bond formation energy is less than bond breaking energy, or bond breaking energy is greater than bond formation energy. The overall enthalpy of formation is negative bracket exothermic if the bond breaking energy is less than bond formation energy, or bond formation energy is greater than bond breaking energy. Now next we want to look at is how to draw the energy level diagram when the enthalpy of formation is exothermic. Now as mentioned earlier, I said the enthalpy formation is an exothermic reaction if the bond formation energy is greater than bond breaking energy. So we look at an example is A2 plus B2. You break the bond in A2 and B2, you form 2A plus 2B. Then 2B and 2A combine to form a bond called 2AB. So the energy level diagram is shown below. A2 plus B2 to form 2A plus 2B, the arrow goes up. That means endothermic reaction. Then for 2A and 2B to combine to form 2AB, that is an exothermic reaction. So the arrow comes down. Now because I said the enthalpy of formation is negative, that means bond formation energy is greater than bond break energy. Then the arrow for enthalpy of formation faces down. Now next is the energy level diagram when the enthalpy formation is endothermic, that is positive. Now it is positive when the bond breaking energy is greater than the bond formation energy. So I'll take an example. X2 plus Y2, you break the bonds, you form 2X plus 2Y. Then 2X and 2Y combine to form a bond called 2XY. So the diagram is shown below. Now from the diagram above, note that the bond breaking is always endothermic, so the arrow faces up. The bond formation energy is always exothermic, the arrow faces down. Now because I said the bond formation energy is less than the bond breaking energy, then the overall enthalpy of formation is positive, so the arrow faces up. Now let's look at an example of calculation. Use the bond energies below to calculate the heat of reaction when a benzene burns in excess oxygen. Now before doing calculation, the first step is write a balanced chemical equation, that is CH4 methane plus oxygen arrow carbon dioxide CO2 plus water. Balance equation, place 2 is oxygen and 2 is water. Then next you have to draw the structure formula for all the substances shown in the equation. That is structure formula of methane, structure formula of oxygen, structure formula of carbon dioxide and water. It is shown below. Now, solution. Bonds broken on the reactant side. You have CH times 4, 410 times 4, that is 1640. We have OO, double bond, times 2, that is 498 times 2, that gives you 996. Now, if you add the 2, you get 2636, which is positive. So it becomes positive 2636 because it is absorbed. Bonds formed occur on the product side. We have CO times 2, 799 times 2, that's 1598. You have HO times 4, 460 times 4, that gives you 1840. If you add the 2, you get negative 3438. Negative 3438, that means it is released during bond formation. Now, enthalpy of formation therefore becomes bond breaking energy plus bond formation energy. That is plus 2636 plus minus 3438. The answer becomes negative 802 kilojoules per mole. Example 2. Use the bond energies below to calculate the ease of reaction for addition of bromine to ethene. Now, equation is ethene C2H4 plus bromine Br2 arrow C2H4Br2. That is dibromoethane. Structural formula is shown below. Now, bonds broken on the reactant side, we have C double bond times 1, 611 times 1, which is equal to 611. CH times 4, 410 times 4 is 1640. You have Br times 1, 1 and 3 times 1 is equal to 1 and 3. If you add the three values, you get plus 2444. Bonds formed occur on the product side. You have CC times 1, 350 times 1, which is equal to 350. CH times 4, 410 times 4, 1640. We have 6 CBr times 2, 270 times 2, that is 540. If you add all of them, you get negative 2530. Enthalpy formation, therefore, is bond breaking energy plus bond formation energy. That is plus 2444 plus negative 2530 is equals to negative 86 kilojoule per mole. Learners, that is the end of the lesson. The next lesson look at in the energy changes enthalpy through experiments. Thank you.